Okay, we now have equivalent ratios. Okay, so we introduced um, ratios in general, and now we are moving on to equivalent ratios. Okay, so for example, and you can highlight this if you want to, it says ratios that name the same relationship are called equivalent ratios. Equivalent ratios can be found by scaling up, meaning multiplying both numbers by the same number, or scaling down, dividing both numbers by the same number. If you notice, we are not adding and we are not subtracting. So, for example, Lucinda makes 6 cups of apple juice with 4 cups of cranberry juice to make apple cranberry juice. Write 3 equivalent ratios for the amount of apple juice to the amount of cranberry juice. So, you have, we'll say, apple, I'm going to make a ratio table. Apple juice, cranberry juice, okay? And my first ratio is 6 cups of apple juice to 4 cups of cranberry juice, okay? And so we can scale down, meaning dividing. And each time we divide, we scale down or multiply, scale up, you must do so by a common factor. In this case, I'm going to scale down, and I'm going to divide by the greatest common factor of 6 and 4, which is 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. Okay, so this means for every 3 cups of apple juice, you would need 2 cups of cranberry juice, and it would still have the same consistency and taste, okay? So I want to, from here, I cannot scale down anymore. I mean, we can go to fractions, but we don't want to do that. Let's keep it at whole numbers. So if I were to scale up, I've already multiplied by 2. If I can multiply by 3, 3 times 3 is 9. 2 times 3 is 6. You could start with your unit rate and scale up and say 3 times 4 and you get 12. And for 2 times 4 you get 8. So this is 3 equivalent ratios right here to this one. 3 to 2, 9 to 6, 12 to 18. Okay? So let's do some more practice. So for questions 1 and 2, using the picture below, write 3 equivalent ratios to describe each comparison. So I have soccer balls to footballs. So I'm going to say soccer balls to footballs, okay? And my initial ratio, soccer balls, 2 soccer balls to 6 footballs, okay? Let's see if I multiply by 2. I'm going to scale up. 2 times 2 is 4. 6 times 2 is 12. And we can continue to scale up by the same factor of 2. So 4 times 2 is 8. 12 times 2 is 24. And we need, how many more? 3 equivalent. So 1 more. 8 times 2 is 16. 24 times 2 is 48. So this still gives you the same, these are all equivalent ratios. And if you notice, it's like doing equivalent fractions, right? Okay. Now I have footballs, so total numbers of balls. So I'm going to start with footballs is my numerator and my ratio. Total number, I'm going to say T for total number. So all of my footballs, I have 6 footballs. And all of the balls together, I have 8. Okay. So let's practice scaling down. Remember, when I scale down, I'm going to divide by the greatest common factor to get my unit rate. I have 6, so 6 and 8, the greatest common factor is 2, so I get 3 to 4. Okay, so 3 times 2 is 6, 4 times 2 is 8. So let's scale up from 6 to 8, excuse me. 6 times 2 is 12. 8 times 2 is 16. And then I could do 12 times 2 is 24, and 16 times 2 is 32. And that's 3 equivalent ratios. Now here's your question. Here's a question I have too. How can I determine if they are equivalent ratios? If you took each ratio and you were to simplify it, for example, number 2, I have 6 to 8, and I'm going to write it as a fraction. 6 to 8, and I'm going to hit enter, and you see my arrows to simplify, simp, and I get 3 to 4. Okay, 3 to 4 is my most simplified ratio. So if you were to put each ratio in your calculator and simplify it as a fraction, and you came up with the simplified as 3 to 4, then you know they are equivalent ratios, okay? Okay. 3 through 8 is to write 2 equivalent ratios for each given ratio. So as you can see, it's written in these multiple forms that we have learned, but when we are developing writing equivalent ratios, we want to write them as a fraction. So 16 to 12. Okay? And so I'm just going to make it like another table. Okay? So let's scale down. Let's divide 16 by 2 and I get 8. Let's divide 12 by 2 and I get 6. Let's see if we can scale down again, because 2 is still a common factor. 8 divided by 2 is 4. 6 divided by 2 is 3. Okay, so these are both equivalent ratios. In this case, we scale down by dividing by a common factor. Now, please note that in this ratio, my numerator is greater than my denominator in each ratio, but that's okay because these are ratios. They are set up as a fraction, but we will never convert this to a mixed number. Ratios compare two quantities. So 2 to 7. Another table. Now, one thing I want you to know and remember about this is that 2 to 7 would be simplified. So we could only scale up. So let's multiply 2 times 2 and we get 4. 7 times 2 and we get 14. And let's continue scaling up by 2. 4 times 2 is 8. 14 times 2 is 28. Okay? Look at 5 to 30. You can make a table. I'm going over here because I'm going to scale down. And I'm going to divide both by 5. 5 divided by 5 is 1. 30 divided by 5 is 6. Okay. And let's scale up by 2 from here. 1 times 2 is 2. 6 times 2 is 12. And if I were to simplify, my ratio would be 1 to 6 every single time. Okay, looking at our next one. 48 to 18. Let's scale down. And this and I'm giving you different ways of looking at it to see, you know, what would work for each one of you. So you can see there are many ways to write equivalent fractions. In this case, I'm going to divide both by 2 because they're both even numbers and 2 is a common factor. 48 divided by 2 is 24. 18 divided by 2 is 9. Now they no longer have any common factors. But, well, 20, no, I lied. That was terrible, wasn't that? Yes, 3 is a common factor. Shame on me. Another common factor is 3. 24 divided by 3 is 8. 9 divided by 3 is 3. Shame on me. Okay. Look at 15 and 12. Oh, sorry, I gotta drink my water. 15 and 12. So I'm going to rewrite this. 15 and 12. Okay. A common factor of both is 3. 15 divided by 3 is 5. 12 divided by 3 is 4. Okay. So as you can see, I cannot simplify this ratio anymore because the greatest common factor is 1. But I can scale up and multiply by 2. 5 times 2 is 10. 4 times 2 is 8. And when simplified, these would all simplify to 5 to 4. And remember, it's okay if your denominator is smaller than your numerator. It's okay. Now I have 36 to 8. 36 to 8. Rewriting this. Okay. So a common factor is 2. 36 divided by 2 is 18. 8 divided by 2 is 4. We can continue to scale down. 18 divided by 2 is 9. 4 divided by 2 is 2. Okay, so 2 more equivalent ratios. Now this time, they're asking you to find values. Fix that. They're asking you to find values. Fill in the box with a number that will make ratios equivalent. So this is like making equivalent fractions all over again. You got to ask yourself, how did I get from 1 to 5? Well, I multiplied by 5. So 4 times 5 is 20. Okay. How did you get from 3 to 24? Yeah, we multiplied by 8. So 7 times 8 is 56 to create another equivalent fraction. How did we get, because we're going backward now, how did we get from 12 to 3? What did we divide to scale down? Divided by 4. 40 divided by 4 is 10. Number 12, looking at it backward, how did I scale down? Or you could say, how did I, well, I'll scale backward. How did I go from 10 to 5? I divided by 2. 18 divided by 2 is 9. How did I scale down to 2? Well, I divided by 7. Okay, so if I'm going to go this way, 5 times 7 is 35. How did I get from 45 to 15? What did I divide by? I divided by 5. So if I'm going to go this way, I would multiply by 5 and I would get 40. Okay. Read number 15. I'm going to take a big swig. Okay. The ratio of a number of students to the number of chaperones on a field trip is 15 to 2. So this is how I like to do this. I'm doing students to chaperones. Now I write out the quantities I'm comparing so I keep my numbers in the right position, because if we don't put our numbers in the right position, our ratio is completely off. So the ratio is 15 students to 2 chaperones, okay? If there are 60 students, how many chaperones are there? So this is where we're making an equivalent ratio. If I have 60 students, how many chaperones do I have? And it's very much what we did up here, finding that value. What do I multiply by 15 to get to 60? Yeah, 4. So 2 times 4 should be 8. So if I have 60 students, I should have 8 chaperones. Number 16. Micah earns 2 points for every 3 questions he answers correctly on a test. If he answered 24 questions correctly, how many points did he earn? So he gets, we're going to say points per question. Points per question. Okay? So 2 points per question for every 3 questions. So 2 points for every 3 questions, okay? So if he answered 24 questions, we got to fill in this hole right here. What did I multiply to scale up to 24? Yes, 8. So 2 times 8 is 16. So he got 16 points for 24 questions, okay? Number 17. Karina makes $27 for every 2 hours that she works. So we're going to say money over hours, okay? And she's $27 for every 2 hours. So that is my ratio, $27 for every 2 hours. But they're telling me she worked 36 hours. So I'm going to scale up. What did I multiply by to go from 2 to 36? Yeah, 18. Okay, so if I multiply, am I right, guys? I'm having a moment, right? 2 times 18 is 36. All right, she worked a lot. So I would multiply 27 times 18. Yes, I'm using my calculator. Shoo-wee, she's good on money. That's some good Christmas money. $486 for 36 hours. Number 18. An 18-ounce bottle of soda contains 216 calories. So my two quantities are ounces and calories. So 18 ounces and 216 calories. Okay, if Sam drinks 6 ounces, so what did I divide by to scale down to 6? Well, if I don't remember my factors, I would do 18 divided by 6, and I got 3. So I would do 216 divided by 3, and I would get 72. So there are 72 calories and 6 ounces. Okay, number 19. The ratio of girls to boys in 6th grade is 5 to 3. So we're going to say girls to boys is 5 to 3. Okay, if there are 406 graders, how many boys are there? Oh, okay. So that's like a big fat thinker, isn't it? So hang on a minute. In order to find this number, you would, if they're saying 400 altogether, you're going to add your boys and your girls. So you're going to add your boys and your girls, and you're going to have 5 plus 3 equals 8. Okay? So that means, hang on, I'm thinking about this. So I just had it written down a second ago. Give me a minute. Okay, I had to think about that. My brain works now. Okay, so I was right. So we're adding all of the students all together. Okay, so the ratio we're trying to create is there are 406 graders. Okay, so I've added boys and girls. So there are 8 6th graders. Okay. There are 3 boys. 3 boys for every 8 6th graders, okay? And if I have 406 graders all together, what do I multiply by to scale up to 400? Well, I'm going to do 400 divided by 8. There we go, 50. Okay, so then I'm going to multiply 3 times 50, and I get 150. So my answer is that there are 150 boys. There are 150 boys. Okay. So down here it says ratios with the same simplest form are equivalent. Determine if the following ratios are equivalent. So here's what you're going to do. You're going to put a ratio 1 to 2 and then 6 to 12. And you're going to simplify. And you can simplify in your calculator. 1 to 2, we already know 1 to 2 is simplified, but we're going to put 6 to 12, and we're going to simplify that and I get 1 to 2. So I'm going to say yes. Okay. I want to find one. Yeah, like this. Watch me. 24 to 18. We're going to look for a simplified. 20 to 15. But Miss Collins, it's going to make me a mixed number. Watch. 24 to 18. Put your fraction. 24 down 18. Okay. And we're just going to keep simplifying. Okay, we're going to keep simplifying. But now you are going to hit your second mixed number button. So it will give you, again, this is the ratio you want to see, 4 to 3. So this gives me 4 to 3. Okay, I'm just going to circle that. 20 to 15. Do I get the same thing? 20 to 15. Simplify. Okay, and now I have that it's simplified, but now we're going to do second mixed number so I can make it improper, and I get 4 to 3. That's what you'll need to do with your calculator, and we can say yes. But Miss Collins, what if I don't have my calculator at school? Well, we'll talk about that in a second. Let's look at this one, 3 to 7. Well, we know it's simplified because the greatest common factor of 3 and 7 is 1, but I have 9 and 28. And if I'm going to simplify by the greatest common factor, I don't know that I can. I'm going to go probably no. 9, 28, simp. It doesn't simplify. So this is a no. No. But look at this one. 48 over 16. 48 to 16. So if you don't have a calculator at home, you can still divide by the greatest common factor. In this case, it is 4, right? Look at me. 4, but is it? 8. 8. 48 divided by 8 is 6. 16 divided by 8, oh, Amanda, is 2. I could have gone again, couldn't I? Yeah. Yeah. Because 16's a factor. Yeah. We're just going to erase that. Because 16 goes into 48. I knew that. I knew that. So 48 divided by 16 is 3. 16 divided by self is 1. Remember, this is a ratio, so you need that 1. 6 to 4 is going to be equal to 6 divided by 2 is 3. 4 divided by 2 is 2. Oh, that's a hard no. Okay. And then again, if you want to continue to use your calculator and simplify, you can. I'm going to say 4 to 10. Sim is 2 to 5. And then 14 to 35. Sim is 2 to 5. And we're going to say yes. And then 24 to 72. 24, 72, simp, simp, and simp. And simp again. 1 to 3. Okay. And then we know 4 to 12 should be 1 to 3. Doesn't hurt to simp. Doesn't hurt to simp. There it is. So this is a hard yes. Yes. And that's it, guys. We got it. We got it. Ooh, look at me not writing it down for you. Now you can see it. We got it.